Hello and welcome to Petals for Your Troubles. I'm Chris and today we'll be having a little physics, in particular, projectile motion. We'll be showing you how to solve a projectile B problem in which the object is launched at a certain angle. An organized way to solve this is by writing down your given, what's asked, your solution, and your answer, in that order. This is aka the GASA method. Anyway, let's get to the problem. In an egg toss competition, Caddy gave the egg an underhand toss with a release velocity of 9.02 meters per second at an angle of 30 degrees to the horizontal. To the pleasure of the crowd, Damien caught the egg at the same height as the toss, without even a fracture to its shell. Now the problem asks us to calculate for 5 things. A. Calculate the horizontal and vertical components of the initial velocity. B. Calculate the time for the egg to reach the midpoint of the trajectory. C. Calculate the total time the egg is in the air. D. Calculate the horizontal distance which the egg traveled from Caddy to Damien. And E. Calculate the height of the egg relative to the release point when it was at the peak of its trajectory. Okay, now first we want to figure out the horizontal and vertical components of the egg's initial velocity. Because the angle is from the x-axis, the initial velocity's x component is equal to the initial velocity times the cosine of angle theta. On the other hand, the initial velocity's y component is equal to the initial velocity times the sine of angle theta. We know that the initial velocity is 9.02 meters per second, and the angle is 30 degrees, which means we could use these variables to solve for the x and y components, as you can see right here. Now we're asked for the time for the egg to reach the midpoint or the peak of the trajectory. Let's call this time ty. We already know the y component of the initial velocity, so the best equation to use would be the velocity of y equals the initial velocity's y component plus gravity multiplied by time. Gravity is negative 9.8 meters per second, and the velocity of y is 0, since this occurs at the peak of the trajectory. Next, let's solve for the egg's total time in the air. Let's call this time tx. Since Damien caught the egg at the same height as Caddy's toss, the time for the egg to go up is the same as the time for the egg to go down. The time for the egg to reach half of the way is 0.46 seconds, so we simply multiply it by 2 to get the total time, which is 0.92 seconds. Next, we're asked for the horizontal distance. You can also call it the horizontal displacement or range of how far the egg actually went. Let's represent this as x. Because we already have the velocity of x, which we know is equal to the x component of the initial velocity, and we also have tx, we could use the equation x equals the velocity of x times tx. Now finally, let's solve for the height of the egg at the peak of its trajectory. This height is the vertical distance or displacement. Let's represent this as y. The equation for y is y equals the initial velocity's y component times t minus 1/2 times g multiplied by t squared. The time we use is ty. Since we're looking for y, it looks like we have all the information needed to solve for the vertical distance, which is 3.11 meters. Now, sometimes projectile motion problems may ask for a variable, and you may find that your given variables cannot form the correct equation to solve for it. Well, don't worry. If you are given enough variables to solve for at least one other variable, you will eventually be able to solve for all other variables of the projectile motion problem. So, don't lose hope. Yeah, don't lose hope. Recap. The velocity of x is equal to 7.81 meters per second, and the velocity of y is equal to 4.51 meters per second. The time it took for the egg to reach the midpoint of the trajectory is equal to 0.46 seconds. The total time the egg was in the air is equal to 0.92 seconds. The total range the egg covered is equal to 7.19 meters, and the highest point the egg reached is equal to 3.11 meters. This has been Petals for Your Troubles Physics. We hope you enjoyed the video. Don't forget to leave a like and/or subscribe. Thanks for watching, and we'll see you next time.